In this video, I'm going to demonstrate how to find an exponential equation that passes through some given points, and I'm going to be using the exponential model y equals ae to the rx. I'm going to be taking each of these points 2, 8 and 5, 1 and substituting them into the equation. For the 2, 8, when I substitute the x and the y into my model, the y is 8 and the x is 2. Likewise, I'm going to substitute the 5, 1, and that gives me 1 for y equals a times e to the r times 5, since 5 is x. I have two equations. They both have the same two unknown values, a and r, so I'm going to be using substitution to solve for those two unknown letters. I'm going to solve for a over here by dividing both sides by e to the r times 2. And then I'm going to be substituting that into our other equation. So instead of a, I'm going to have that new expression for a that I got on the left-hand side, which is 8 over e to the r times 2. And then I still have e to the r times 5 over here. As a little side note over here, e to the r times 5 over e to the r times 2. We usually write the number in front of the letter just for more familiarity. And when we have two powers that are being divided, we can just subtract the exponents. 5r minus 2r is 3r. So this expression simplifies to be e to the 3r. So that leaves 1 equals 8 e to the 3r. I'm going to go ahead and finish solving this equation. I'm going to divide both sides by 8. I can note my step, if you like, by using a little indication, either divided by a symbol or the word div. So I divided both sides by 8. Oops, I wrote a 9 there. Let's change that to an 8. If you're showing your work, you can show it in different ways. This is one way to show it. To solve for an exponential equation, when we know the base is a number, 2.7 or e, the exponent is not quite known, we use a logarithm. I'm going to use the natural logarithm. Not only is it the standard logarithm for calculus, it does have a base that's equivalent to e, which is our exponential. The logarithm base e and the exponential base e are inverses of each other, so that just leaves 3r is equal to ln 1/8. And then I'm dividing by 3 on both sides, or multiplying by a third. It makes it a little easier to write. And that's my expression for r. It is possible to simplify this expression for r, but right now I'm just going to leave it as 1/3 ln of 1/8, just so that I can demonstrate the steps to do this without getting a little bit lost in some of the simplification techniques. Right? If I was showing all my steps, I would do the ln of both sides. I would simplify, and I would divide both sides by 3. All right, we now know the value of r. We are halfway home to finding the equation. The other letter that I need to know is a, but we know what a is. A is 8 divided by r times 2. So let me use the information that I just got for the value of r and plug that into my formula. Well, we know what r is, so instead of writing r times 2, we can write 1/3 ln 1/8 times 2. I'll just clean that up a little bit by multiplying the 2 times a third. 2 times a third is 2/3. So this is 8 over e to the 2/3 ln of 1/8. All right, for this one, I'm going to put it into Desmos. 8 over e to the 2/3 times ln 1/8. If you check on Desmos, that gives you a value of 32. I don't believe you can see that. There you go. 8 divided by e to the 2/3 times ln 1/8 is equal to 32. So I can simplify that computation for a as 32. This gives me the values of both a and r. And once I have the values of a and r, I can write my equation. Remember, the model I'm using is aer to the x. So now I know my equation based on this value of a and this value of r is going to be y equals a e to the r times x. So that's an example of how to find the exponential equation that passes through a couple of points. The value of r simplifies to be negative ln of 2. So it might be a nice exercise to simplify 1/3 ln of 1/8. It does simplify to be negative ln 2. If you'd like to do that together, just let me know and I can walk you through the steps. But it's a nice little challenge to see if you can do yourself. It is not necessary to simplify that exponent to get the correct answer. Okay, so please reach out if you have any more questions or would like to see another example of finding an exponential equation that passes through some given data.